I decided to go ahead and do another example on the quadratic formula because I was thinking about, we're about to hit some word problems here, and the quadratic formula could come handy on some of those. They could be calculator heavy at times, but we'll try and give you some initially that'll be factorable. But here's one right here. So we have 2z squared plus 9z minus 5. Well, your quadratic formula starts with x equals 2. But in a lot of application problems, our graph may change to represent the real world, distance, time, height, speed, things like that. So we may use different letters on our graphs. So very often, a lot of people just randomize what variable we're going to use. Just think of these as the x's. So we're going to again go ahead and use this quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. I almost said it. Going to pop goes the weasel. Have this memorized. You want to write it down for every single problem you do, and that will definitely help. Then we check to say, make sure it's in standard form. Sometimes the 5 could be over here. It could be 2z squared plus 9z is equal to a positive 5. Just subtract a 5 and get it back over to this side. So a is equal to 2, b is equal to 9, and c is equal to a negative 5. And I know I'm going to have two solutions by looking at it. But I'll explain that in class a little bit tomorrow, something called the discriminant. So let's get started, and I'm going to plug in. As always, I like to use parentheses when we're first starting out on this. Eventually, you're going to get good to where you can knock these out pretty fast. But I want to be very careful. Actually, that's going to be a z instead of an x, but that's all right. Then we plug in. In goes our 2. So our 2 goes right here and right here for our a. Our b is 9. It goes there and there. And our c is a negative 5. See, I have a negative times a positive, so I know that's going to be a positive. Time to clean it up. So we have negative 9. Both roots are represented by this plus and minus. This is going to be 81. Put the whole thing. If you're using a calculator, use those parentheses. So that's going to be a negative 8 times a negative 5. That's going to be a positive 40. So I'm going to have plus 40. And then all this over 4. So what I have is negative 9 plus or minus square root of, looks like 121. All right. That may sound familiar to some of y'all, but if not, we're going to keep pressing. Okay. So if you don't know the square root of 121, we can always use a calculator. Again, I gave you a perfect square worksheet. I want you to have that memorized. But if you ever forget, you can just come over here and go ahead and do, well, we're going to do step 1 and step 2. I mean, we're going to take the plus sign and the minus sign, so it doesn't matter which one you do first. Oopsies, that didn't work out. Let's get this back into frame. Wonder what happened. Well, bummer, there we go. Now it's not quite where I want it to be. I don't like this. I'm sad. Down you go. Okay, so let's get that erased. My cat is staring at me. I closed the door because he was annoying me. So what we're going to do is make sure that we do negative 9 plus square root of 121 over 4. And negative 9 minus square root of 121 over 4. And let me show you the calculator practice on this. So what we have here is, I'm going to put this top part in parentheses. I need y'all to practice this because you are going to be doing a lot of, so that's going to be negative 9. I should have put that in parentheses. Plus square root of, so that's going to be right above here. And that's going to be 121. Y'all use the TI. But it's going to be similar. I'm typing it as if I'm using a TI. This calculator has a different feature. So that would be 0.5. The reason 0.5 is because you're going to find that when you do the square root of 121, it is 11. Okay? Have those perfect squares memorized. So that's negative 9 plus 11 over 4. So that's negative 9 plus 11 over 4. And negative 9 minus 11 over 4. That's going to be 2 over 4. Hey, my wife's calling. She's lost on the road. Okay, 1/2. And that's going to be a negative 20 over 4, which of course is equal to negative 5. So my two solutions z is equal to 1/2, and z is equal to -5. This is actually a factorable problem. We get to solve this by factoring. What times what is equal to -10 when added together gives you a +9. And that would, of course, be a 10 and 1 factor when we split the middle. But I just wanted to show you another example because, hey, my wife is out and the house is to myself and it's all nice and quiet. Okay, see you in the morning.